Okay. We've got this giant excavator here used in road construction. It can apply a maximum vertical force of 2.25 times 10 to the fifth newtons. If it can vertically accelerate a load of dirt at 0.2 meters per second, what is the mass of that load, ignoring the mass of the excavator itself? Excavators, excavators, excavators. So what we're looking at here, this is a 6-E2 problem. Vertical forces. Okay, so it's still going to be an F equals ma problem, but we're acting in a vertical direction. So let's imagine that our excavator here, let's just draw this thing so we get an idea of what we're looking at. I don't know, it's got like an arm and a claw. It doesn't look like anything. But it's just hauling up some dirt. So here's like a, I don't know, it's got a mound of dirt or something like that it's picking up. Okay, the dirt's being picked up. So if we wanted to draw a free body diagram of this, what we have here is we've got some dirt, and this dirt has a weight associated with it, and the maximum lifting force we can get out of this excavator here, the maximum tension from it, I guess we can call it a tension. If you'd like to call it a force in the arm, I guess there'd be nothing wrong with that. But let's just call it a tension because we're kind of lifting this up. There's some force in that arm there. The maximum vertical force we see here is 2.25 times 10 to the fifth newtons. That's a lot of newtons. And it can vertically accelerate a load of dirt 0.2 meters per second. So our acceleration here is 0.2 meters per second squared, excuse me, and that's going upwards, okay? Now, if it's saying it's accelerating upward and this 0.2 is positive, that means technically speaking, they've started to consider up as positive and down as negative in the problem. If you wanted up to be negative, then you'd have to change that acceleration to a negative quantity. So just be aware of that. If we want to figure out what's the mass that the excavator could lift, like what's the maximum mass if we ignore the excavator, then when we go and set up F equals ma, we're like almost done with this problem. We're like 70% done with the problem. Yay! If we do that, we're going to have a tension minus the weight equals ma. And if we go ahead and plug in a bunch of numbers, we've got 2.25 times 10 to the fifth minus weight. And remember, weight is equal to a mass times gravity. That's actually F equals ma right here, acceleration due to gravity. So what we can actually put in is, instead of putting in the W for weight, we can put in the mass we're looking for times good old 9.8. And that has to equal the mass we're looking for times, well, the acceleration that we have, 0.2. If we want to go ahead and solve this, at this point, we're basically done here. We need to recognize that these are like terms. It's an acceleration multiplied by a mass. So if we add 9.8 m on each side, remember, even though it says m times 9.8, you can just move that multiplication, you can flip it. So these are like terms. What we'll have here then is 2.25 times 10 to the fifth equals, and then 0.2 plus 9.8 is exactly 10. So 10 meters per second squared newtons times the mass. And to solve this, we just divide by the 10 meters per second squared. We don't even have to throw this into a calculator. We know that when we divide by 1, we get the same number, but since there's a 0 here from the 10, it's actually just going to cancel out one of our orders there. So our mass here is 2.25 times 10 to the 4 kilograms. And that was a much easier problem than anything we've been doing for the past few days. But in the end, we still did the same thing. We set up a free body diagram, we labeled our forces, we set a direction, and when writing out F equals ma, for every force we had in our diagram, that force went into the net forces of our force equation, F equals ma there. From there, it was just math and solving out. What I would be looking for on the test would be this equation right here, okay? That's the important equation. That shows me you know what forces go in for which values, and that you set the equation up properly with the proper sign. So that's what I'm looking for if this equation would pop it up on a test. With that though, as my fingers crack, that problem's finished. That's a 6-E2 vertical lift problem. Any other problems people would like to see?